In this video, we are going to talk about how to go through the elements in a tree. In other words, how to traverse the elements in a tree in order to get them out in some sort of order. So, because trees are a nonlinear data structure, there are multiple different options for what order to get the data elements or visit the nodes out in. So we're going to talk first in this video about what's called pre-order traversal. The idea with pre-order traversal is that we're always going to visit the parent of a node before we visit the node itself. Or alternatively, before we visit the children of a node, we're always going to visit or deal with the node itself. For example, print it out or put it in our list of the elements in the tree. So, with pre-order traversal, we're going to first visit the node we're in, and then visit the children after that. So, here is the algorithm for pre-order traversal on a binary tree. In order to traverse a tree, which remember a tree is represented as a single node, the root of the tree, so we would call traverse on the root. In order to traverse a node, we're first going to visit the node itself, like printing out the value of A here, and then we're going to traverse left, call this procedure on B, and then when that finishes, we're going to traverse right, i.e. call the same procedure on C. So let's see what this looks like as we execute it. So we call traverse on the root, which is A. So first that's going to say visit self, so I'm just going to write out the result and say that's what visiting is. So we'll say that we're going to print out the A, and that's going to be our definition visit. Then we're going to traverse to the left node. Okay, so that's going to call traverse again on the node B. When the traverse function starts, the first thing it's going to do is visit the node that we are, visit the self, so that's going to print out B, and then after doing that, it's going to call traverse on the left child, which is D. Once we're in traverse on D, the first thing that's going to do is visit D, and then it's going to try to traverse left, but there's nothing there, and so I didn't show it in the pseudocode here, but if node is null, we return back. And so we can't go left and we can't go right, and so traversing D finishes, we go back to traversing B. In traversing B, we did the visit self, we did the traversing left, so what remains is doing the traversing to the right, and so that's going to take us to traverse E. When we get in traverse E, the first thing to do is visit the self, and then again going left doesn't go anywhere, and going right doesn't go anywhere. So then when we return from traversing E, that's going to put us back in traversing B, and traversing B, and so that's going to put us back in traversing A. In traversing A, we just came back from doing traverse left, so the remaining thing to do is traverse right. So we're going to traverse down here to C, we're going to visit C, and then traverse left, and that's going to print out F. And then there is no left or right to go from here. We go back up to C, there's nowhere right to go from here, so we come back to A, and then we exit out, and our traversal is done. And so this is a pre-order traversal of this tree. Pre-order meaning we always visit the node itself before visiting either of its children. So determining the pre-order traversal of this tree by executing this pseudocode in our head is a little bit tedious and error prone, and there's a shorter way to do this. What we can do is we can draw a border around the tree, enclosing it as tightly as possible. Technically we could call this circumscribing the tree. So our border tries to enclose the tree, but of course never crosses the tree itself. And then what we can do is wherever our border goes to the left of a node, we visit that node. So the very first node we go to the left of is A, so we print out A. Second node we go to the left of is B, so we print out B. The third node we went to the left of is D, so we print out D. The fourth node we went to the left of is E, so we print out E. Then the next node we go to the left of after that is C, so we print out C. The next node we go to the left of after that is F. Let me show that again and write the letters out this time. So, first going to come down to start our going around the tree, and we're going to come to the left of A, so we're going to write A. We're going to continue coming down, we come to the left of B, so we're going to write B. Continue coming down, go to the left of D, so we write D. Come back up inside here, because we're trying to hug the tree as tightly as we can, and come back down, and we'll go to the left of E, and so we write E. Come back up, hugging the tree as tightly as we can, so go all the way in here, eventually come over here, come to the left of C, and so we write C, and then come to the left of F, and so we write F, and then we come back up here, and there's nothing more that we come to the left of, and we come back up to A, and we're finished. So, this is the pseudocode for pre-order traversal. Pre-order traversal means that we always visit ourselves before traversing our children. And an easy way to do pre-order traversal by hand is to draw a tight border around the tree, and as we're drawing the border, whenever we go to the left of a node, we print out or we visit that node. So A, B, D, E, C, F, and that's it for this particular tree.